Solving proportions. Proportion says that two ratios are equal. When solving a proportion, you can use cross multiplication. And when cross multiplying, we multiply the denominator of one fraction to the numerator of the other fraction. So let's look at an example to see how we solve. So example 1. A conductor has a resistance of 1.85 ohms and is 835 feet long. The second conductor, with the same diameter as the first conductor, has a resistance of 3.775 ohms. Find the length of the second conductor. So we're going to use this proportion to find the answer. So we can see that the length is proportional to the resistance. And so we need to solve, when you have a larger resistance, what does the length have to be? So how we do this is we're going to cross multiply. And so we cross multiply by multiplying 835 times 3.775, and then we're going to multiply 1.85 times x. So let's go ahead and do that. So we have 835 times 3.775, which is equal to 1.85x. Then we need to get x by itself. So what we do is we just go ahead and divide both sides by 1.85. So this gets rid of it here, and now we're left with it just on the left-hand side, and that's how we find x. So let's get our calculators out. So we go 835 times 3.775, which is equal to 3,152.125. Next, we're going to divide by 1.85, and we get 1,703.85. So what we get is 1,703.85. And that would be the length of the second conductor. So you can see when we look at our proportion that when we went from 1.5 to 3.775, we nearly doubled in size. And when we went from 835 in length, we then went to 1,703 in length. So we nearly doubled again. Now let's look at another example. Example 2. A Wheatstone bridge circuit has the following resistance, where R1 is equal to 100, R2 is equal to 5,000, and R3 is equal to 500. Find the value of Rx. Use a formula for the resistance in a Wheatstone bridge to help solve. So here's our Wheatstone bridge, and we're solving for this Rx, given the following three resistance. So let's go ahead and just fill in our numbers into our proportion. So we have Rx, which is unknown, R3, which is 500, which is equal to R1 on the top, and then on the bottom we have 5,000. Now we're going to cross multiply. So we cross multiply with the numerator of one to the denominator of the other, and then we do it the same for the other two. So on the left hand side we can end up with 5,000 Rx, which is equal to 100 times 500. Then to get Rx by itself, we're just going to go ahead and divide by 5,000 on both sides. And now we're just left on the right hand side. And so we can find Rx by first getting our calculators out. We're going to go 100 times 500, and then divide by 5,000. And we're left with 10. So Rx is equal to 10. Now let's do another example. Example 3. Find the value of x and y in the following pairs of similar triangles below. So to solve for two triangles where one is known and this other one is not known, what we do is we can set up a proportion. So we can go, what's important is we keep x over 6. So let's solve for x here, which is equal to 10 over 12. So we keep it the same sides on the top and then on the bottom. So we have x over 6 and 10 over 12. Then we would just go ahead and solve like we've been solving for. So we multiply the numerator of one to the denominator of the other, and also we'll do it with the other two numbers. So now we're left with x times 12, so that's 12x, which is equal to 6 times 10. Then to get x by itself, you just go ahead and divide by 12 on both sides. So now we're left with 6 times 10, which is 60, divided by 12, which is 5. So x is equal to 5. Now let's solve for y. So what we're going to do is put y over 6, because we need to have one known value on the unknown triangle for y. And then we're going to go 8 over 12. So we have y over 6, which is equal to 8 over 12. Next, we need to go ahead and cross multiply. So we would go 12 times y, so 12y, which is equal to 6 times 8. Right here. So 6 times 8. Then we need to divide by 12 on both sides. So 6 times 8 is 48, divided by 12 is 4. So we would say y is equal to 4.